Hello and welcome back to another session. AWS offers a wide range of database services, and in today's session we are going to see one among them, DynamoDB service. It's widely known as NoSQL database, meaning it's a non-relational database, and it's mainly used to store your data as key value pairs and doesn't have any specific schema attached to it. Due to this structure, it helps in storing and accessing data really fast. AWS claims that DynamoDB can handle 20 million requests per second, which is insanely high and helps in gaming and mobile applications, internet applications, or any other applications that needs to access data with very low latency. Now let's get into console and see how to create a DynamoDB table with the correct partition and sort keys and index, and how to choose the appropriate capacity mode for your table without throttling data access, and finally how to access the data itself. Let's get into the console. Okay, so now we are in the AWS console. First, let's get into the DynamoDB section. You can see all the AWS offered database services here. And let's select DynamoDB for this session. Let's first start by creating a table. You have to select Create Table. And there are only two mandatory fields that you have to specify here. It's that simple. There is no complex instance specifications or maintenance window that are required here. Rest of the fields are either optional or has default settings. First, let's give a table name, which can be anything following the standards mentioned here. I'm going to use a table of books as an example today, so let's call it as books. Next is a super important field, which is the partition key, also known as the hash key. This acts as the primary key of your table and has to be unique, and if you are not using a sort key, this has to be unique. DynamoDB uses this partition key value as the hash value to store and retrieve your items from different partitions. So you can select one of the types here, and I'm selecting author as a partition key. I'll explain this in detail once we load our table with some data. And next is the sort key. Sort key is optional, which is also known as a range key. So if you specify a sort key, then the partition and the sort key together has to be unique. So they can act as a primary key put together. So in our example, we called it as book title. And that's it. And other than that, you have some settings. You have three options under it: read and write capacity, secondary index, and encryption options. So let's customize those. So by default, you have the provisioned mode selected. And under that, you have two capacity modes to be set, that is read capacity and write capacity. So you have an option to turn on auto scaling, wherein if you reach the target utilization, then DynamoDB automatically increases the capacity units. Or if you're using less than the target utilization, then DynamoDB reduces the capacity units. So this is read capacity, that is reading the data from the DynamoDB table. And you can either select the auto scaling option, or you can turn off like this. And if you are turning off, then you have to specify the provisioned capacity units, which is a fixed rate. And if you are exceeding this provision capacity, then your table will throttle and you will not get back the data. So you should be wise in choosing this. And similarly, you have to set the write capacity as well. You have an option to turn on auto scaling, or you can turn off. And both these are very important because your results will be returned based on the read capacity, and your updates and then addition will be done based on the write capacity. And if you're choosing on demand, this is totally controlled by DynamoDB. You need not worry about either write or read capacity. And next, moving on to secondary index. So secondary index is like any other index, where if you don't have your use case to directly query based on the partition key and the sort key which is selected in the beginning, you can set another sort key, with the same partition key in case of local secondary index. And in case of global secondary index, you can set a different partition key and a sort key as well. So in this example, I'm going to choose year as another sort key and the data type as number. And you have to specify an index name so that you can query under that particular index. So the partition key here will remain same as the base table, but the sort key is year. And then you can select the particular attributes which has to be projected in this particular index table. So you can either select all the attributes in the base table, or you can specify only the keys or even certain specific attribute names. So in this case, let's select all so that it projects all the data which is there in the base table. So we have created a local secondary index, and just keep in mind that local secondary index can be created only at the time of provisioning the table, because the partition key is same as the base table. Whereas global secondary index, you get to specify both partition and a sort key. Both can be different from that of the base table. So you can create now or even after provisioning the table. So this is going to use a totally separate capacity than the base table capacity. So initially when you're creating the table, it is actually set similar to the base table capacity, but then you can change or edit it after provisioning the table. Whereas in the local secondary index, you have to the local secondary index shares the capacity same as your base table. So in case of global secondary index, I'm choosing category as the partition key and book title as the sort key, and similarly giving a name, and then you get to choose whether you want to project all the attributes or just the keys or only certain attributes. So you will get a better understanding of this once we start loading some data and then see how to query them. So for now, just know that you can create two types of index and you can query against those index in addition to our base table partition keys. And then you get to select encryption at rest. So encryption at rest, you have three options, either DynamoDB owned encryption key or your own key or AWS specified KMS key. So we are going with Dynamo key. That's it. Let's create the table. Okay, so the table is getting created. It takes a couple of minutes. So as you can see, it displays the basic information like the partition key and the sort key. And then we have two index provisioned here. So one is the local index and the global index. And it also displays the read and the write capacity modes. So the table has been created now. So this is the overview of the table. So before we look at each of the settings of the table, let's quickly go ahead and load the table with some data so that we can query the table and see how it works. So in order to load the data with the initial set of sample data, we can do it through AWS CLI. So I have defined a JSON here. So DynamoDB accepts JSON format. So where you have to give the table name, and then you can specify that it's a put request because you're going to create the items, and you have to specify each item as an object. So the key will be your attribute name, and then you have to specify the attribute value as a map. And this S here is the data type, so S meaning string. So you have to specify the data type as well as the value. So in case of n, it is number. And like this, you can define all the items here. And also notice that it's not required for all the elements to have all the attributes. So as you can see, in few of them, the book series exists, but in few the book series doesn't exist and it doesn't throw an error. And as you can see here, there is addition, but in the other items there was no addition. the only required values are the partition and the start key. So once you have a JSON defined this way, you can run a simple CLI command in order to load this data into the DynamoDB table. So we are going to use batch write item here, and then you can specify the file name. So to execute this, get into your terminal window, and then here you can I have already used AWS configure in order to set the access key and secret key which has access to create items in DynamoDB. So I'm just executing the batch write item command, and as you can see, it says unprocessed items and it has blank, so that means all our items are processed. So this will take a couple of minutes to be loaded in the table. So in the meantime, let's go and take a tour of what's there within the table. So in the overview, in general information, you can see the partition key, the sort key, and the provisioned capacity mode. So this page actually gives you the overall overview of the settings which are selected for your DynamoDB table. And you can quickly look at the item summary, that is the item count, table size, and the average item size. So right now it's 0 bytes. Actually, each item can be up to 400 KB in DynamoDB. And then you can see the index which we have specified during the table creation. We had two, that is global and local. As we mentioned before, you can create only a global secondary index after provisioning the table. You can't create a local secondary index. You can create it only at the time of provisioning the table. And you can remove a global secondary index, whereas you can't modify the local secondary index. This is one of the important points. And then if we go into monitor section, you can see the CloudWatch metrics which is associated with the table. So it gives you the real-time metrics of the read usage, read capacity usage, what are the requests that are being throttled, and similarly the write usage. It gives you for the base table as well as for your index, and also the latency. So this is useful in case of any performance monitoring. And then replicas, by default, your AWS will replicate your DynamoDB within the availability zones within a single region. But if in case your use case requires the table to be duplicated in another region, then you have to specify it explicitly in replicas. And backups, by default it is disabled. You can enable point-in-time recovery so that your data is saved for 35 days even after your table is deleted, or you can even create on-demand backups. And even you have an option to export the data to S3, or you can stream the data by using a Lambda, and you can manipulate or do some calculations with the data which is stored. So whenever you update, the data will be streamed into a Lambda and you can do your own calculations there. And then at any point you can change your read or write capacity. As it's a provision mode and auto scaling is turned on, if you are using the DynamoDB heavily, then your capacity units will automatically be increased or decreased based on your usage, or you can change the capacity mode. As well as you can set something called as TTL, which is something which automatically deletes the expired items in your table. So each item can be associated with a TTL, and DynamoDB removes that row once it reaches the TTL value. So as you can see now, the data has been loaded into our table. So I had 13 items specified in the JSON, and all those are created here. So each item is in a JSON format again, and it has the key and the value pair. So as you can see, it has author, book title, price, series, category, and year. And author and book title are only mandatory values, and the rest you can either have them or you can leave them out. And there are three formats. One is the JSON format, which we saw right now, or you can view them as the DynamoDB JSON, which includes the data type as well. Or the third one you can see as a form. So as you can see, it displays the same attribute name and the value along with the data type, but as a form, and it's more interactive. You can remove all other fields except for the primary and the sort key, and you can add a new attribute, and these are the supported data types. So string, number, boolean, binary, and null, all these are the primitive ones. And then you have set, list, and map. So set is a unique list, and then list is a combination of all the data types, and then map is a key value map. So you can add any type of this attribute and update an item at any point. And as you can see, all the fields are not mandatory here. So in this case, addition is present only in case of the first item, and all the other items doesn't have addition. And this is one thing which is special in NoSQL. You do not fill null values in the other items. You can just leave them blank, and the field will not even exist in the other items. So DynamoDB supports these type of complex data types. So you can have the data type addition here is a list of map, and under the map you have primitive data type stored, which is number. So DynamoDB supports up to 32 levels of this. So you can specify year, and then under year you can specify even one more level, or you can go up to 32 in that case. And you can insert any field at any point. So you can add something to the edition itself. You can add another map or another list, or you can add even to the main attribute item. So it's very flexible. You can throw in any data at any point. So that's why it's schemaless, and it's very helpful in maintaining changing data, and that's why it's useful in a lot of internet applications. Okay, so now moving on to the operations that can be performed in DynamoDB table. You can do either query or scan the table. So in case of query, you have to definitely specify the partition key. So without specifying the partition key, you can't query a table. So this is querying the base table. So first you have to specify the partition key to get the data. Alright, so I have selected J.K. Rowling for the author. So it returns me only the data which is associated with J.K. Rowling. But now I can even specify a sort key. So in this case, if I say just begins with, and if I say Harry, then it will return me only only that specific subset of data, and it will eliminate the data which doesn't match that criteria. So by this you can effectively query your table and get only the relevant data. So querying is very fast because you are picking a specific partition and you're getting the data only from that specific partition. So querying returns the data really fast. But the only drawback is that you can query only with a specific partition key of that base table. Or else you can add additional filters in addition to your partition key. So you can't leave out the partition key. You have to specify the partition key, and in addition to that, you can specify few more filters. So in this case, if I say rating, and if I say number and equals 5, then it will return me only the books which has a rating of 5. So notice that even here we are still continuing to use the partition key, and in addition to that we are filtering with few more attributes. So now what if you don't want to query using the partition key? And all these consumes a read capacity. That is what we have provisioned here. So as all these items are very, very small, it consumes only less read capacity. So the read capacity consumption depends on the size and the number of items. So now if we want to query the table using a different partition key, like we don't want to query by using this, that's where index comes handy. So what you can do is, instead of selecting books as a main base table, we can select one of the index which we have defined. So I'm selecting the local secondary index, author and year. And in this case, you can see that still we have to specify the author, but the sort key is different. So we are sorting it based on the year. So you can specify, I'm just saying year more than 2000. So it only returns the books which are released after 2000. So this is one way of querying the table with a different partition and the sort key. So if your application requires that type of querying and it's done more frequently, then you can add it as a separate local secondary index so that your base table is not heavily burdened. Okay, so this is one way. And now what if you want to use a different partition key itself? So in that case, we can go for global secondary index. That is where we have defined category index. So we have used category as the partition key here and the book title as a sort key. And however, remember that even in case of index, both the partition and the sort key put together has to be unique. And say I have to query, I have to get all the books which has category as adventure, then I can put in that and run the query. So now we get all the books which are under the category adventure. So in addition to the partition key, we can also specify the sort key and get the data based on both the category and the book title, that is partition and the sort key. So if in case you want to query the whole table, that is scan the whole table, then you can just scan or run the scan against the whole table, which returns all the items in the table. And in this case, you need not specify any of the keys. You have to just specify filters. So what happens is DynamoDB has to go and check all the items in the table in order to return the results back. So this is a bit costlier operation to be performed. So it's always better and recommended to stick to query, and you shouldn't be scanning your table heavily. Scan should be used uh, very wisely, and you should limit the usage of scanning the table. So these two are the operations that can be performed. That is, you can either query the table or you can scan the table. So all these we did from the console itself. And in addition to querying and scanning the table here, you have another option called as particle editor, which was recently introduced by DynamoDB, where you can specify SQL-like statements. So as you can see here, there is a separate section for that. So you can specify traditional SQL-like statements here. So select star from books. So it will return all the items in the book. It is equivalent to scanning the table itself. So some of you may be more familiar with a SQL-like structure. So these statements are helpful for you guys. So you can even query, that is, you can specify the author and where clause, or you can add even you can add on and or and all those things. You can do an update or even delete an item using using the query statements here. But the things which you can't do is still you can't do union or intersect between two tables because these are not relational tables. So basically you can't do union or intersect. You can only run these type of select, update, or delete statements. So this is useful for anyone who is interested to just use the SQL-like statements. So in addition to the console and the particle editor, you can access the data by using CLI. So there is a whole set of CLI commands. In fact, whatever we did from the console can be done through CLI. So like listing the tables, and you can even create the tables by specifying the attribute definitions, key schema, local secondary index, global secondary index, and you can batch write item. This is the one which we ran in the beginning of the session. And then you can run get item and delete item, or even the particle statements can be executed through execute statement, and you can specify the statement that needs to be executed. So all these can be run through CLI commands using your command prompt or terminal window. So this particular document has the whole list of CLI commands which DynamoDB supports at the moment. So you can see the entire list here. You have all the options: batch get item, batch write item, and the documentation is pretty exhaustive, so you can see all the data and what's the format which is required. You can try few of your own. And the next option is you can use SDKs which are provided by AWS. So it comes in all these 7 different languages: Java, JavaScript, Node.js, .NET, PHP, Python, or Ruby. You can use one of the languages and automate the whole setup. So as Python is pretty popular nowadays, I've just used the documentation for Python. So there is a library called as Boto3, and if you can import that library and start playing around. So you have to import Boto3, and then you can get the service DynamoDB and start creating a table. And the syntax is pretty straightforward. It's not complicated. And this is an async call, so you have to wait for till the table gets created, and then you can create a new item within the table, or get the item using get item. And all the operations which are performed through console and the CLI can be done through SDKs as well. So these are the 4 options, either through console or particle or CLI or the SDK. So these are the ways how you can access the DynamoDB table. Okay, so hope you found this session useful. If you have any questions, please leave them in the comments below. See you soon in the next video. Thank you.